in this lesson we're going to compare various types of fuels. Now before we do that, let's just fill in the statement here. We say that a fuel is a substance which readily reacts with oxygen. Okay, and by fuel I mean a combustible or chemical fuel, not referring to nuclear fuels, which is a different type of fuel. Okay, so they readily react with oxygen, and what you want to get from a fuel is obviously energy. So fuels react with oxygen to produce energy, so that's what we want when we burn a fuel. And so in your GCSE chemistry course you've come across around about 5 different types of fuels, and let's just quickly go through those. Okay, so the first one you're familiar with is carbon. You came across that, for example, in the blast chamber used to extract iron from its ore, and a type of fuel which really contains pure carbon is called coke. So coke is a solid fuel which is very, very rich in carbon. Okay, after that we've got hydrogen. Okay, so hydrogen is a very good fuel, we'll look at that in a minute. And then in organic chemistry you come across a whole load of compounds called hydrocarbons. So these are molecules which are made from the hydrogen atom and the carbon atom. A lot of these are also very good fuels. And then, well, alcohols are almost hydrocarbons. They're made mainly from hydrogen and carbon atoms, but they have the odd oxygen atom thrown in the OH functional group. Okay, and then finally the 5th type of fuel you come across is carbohydrates. Are very good suppliers of energy, and carbohydrates are made from carbon, hydrogen and oxygen, and examples of these are glucose, sugars, sucrose and starches. Okay, all of these are types of carbohydrate, and so a carbohydrate is a molecule which contains carbon, and the hydrogen and oxygen are always in the ratio of 2 to 1. So the formula for glucose is C6H12O6. Alright, so it's always a ratio 2 to 1. So in glucose it's 12 to 6. So let's just have a look and see what happens to these when they burn in oxygen. Okay, so the first thing is the thing that we're after when we burn fuels, and that's energy. So all of these produce plenty of energy when they react. So that means that these combustion reactions are highly exothermic. Their changes in enthalpy are very negative. But let's just have a look at the products. So when carbon burns in oxygen, you're going to get carbon dioxide. Now we're referring here to the complete combustion of the fuel, and particularly in the case of carbon and hydrocarbons, alcohols, carbohydrates. So we're referring to what happens when there's an ample supply of oxygen. I'm not going to be looking at the incomplete combustion of the fuels in this lesson, but this will be covered in a later lesson. Okay, so the carbon burns in oxygen to produce carbon dioxide, and then hydrogen, well, that will react with oxygen to produce water. Right? Water is the oxide of hydrogen. Carbon dioxide is one of the oxides of carbon, and as you might expect with the other 3, because these are all rich in hydrogen and carbon, okay, then the products will be the oxides of hydrogen and the oxide of carbon, which is carbon dioxide and water. So in the complete combustion of these 3, hydrocarbons, alcohols, carbohydrates, you're always going to get the same product, carbon dioxide and water. That's not true in the incomplete combustion, so you need to go on to look at that further lesson on incomplete combustion. So we've got that. Now what we're really doing here is we're just comparing the energies released from these fuels, and so we're just going to have a look at a little energy chart. So we've got in our table carbon, coke, we just mentioned that's used in the blast furnace for the reduction of iron oxide, and then you've got methane. This is found in natural gas. So in natural gas there's a very, very high percentage of methane. There's a bit of propane and butane also thrown in, but mainly methane. And then you've got octane, which is the principal molecule in petrol, and then we've got glucose, an example of a carbohydrate, and our friend hydrogen at the end. Again, when these react, as I mentioned just before, that with carbon you get carbon dioxide. With the hydrocarbons, methane and octane, you're going to get carbon dioxide and water, and obviously these equations are balanced. And then with the carbohydrate you also get the same, carbon dioxide and water. And then finally with hydrogen you just get the water. So all of these equations are balanced. What we're looking at and sort of more interested in here is the energy that's released. Now, at first glance you look at petrol and you think, wow, that really chucks out a whole load of energy per mole. But that's kind of what you'd expect, because if you look at the petrol molecule, you've got 18 atoms of hydrogen here. So these two molecules of petrol are reacting with 25 molecules of oxygen. So there's going to be a lot of bonds being broken and formed, in this single reaction, which is going to release quite a lot of energy per mole. If you want to get a better idea of the efficiency of these fuels in releasing energy, then it's really better to look at the kilojoules produced per gram. Okay, so that actually is very important if you want to find a fuel, for example, that will fly an aircraft or even to take a rocket up into space. Okay, you're not just interested in the amount of energy that's produced, but the actual weight of the fuel is very important. So if we look at this other figure, you'll notice a very different story here. The fuel that comes out at the top of the list now is hydrogen. Okay, that releases a whole load more energy than any others, nearly 3 times as much energy per gram as petrol. So hydrogen is a much more practical fuel as a rocket fuel. Okay, much better than the kerosene or petrol, for example. So let's have a look and see where we get this figure from. Okay, the kilojoules per gram. And while we're doing that, we're going to compare the energy released per gram for petrol and that for hydrogen, because there's a lot of interest in using hydrogen as a fuel for cars these days. Okay, so before we just discuss that, what we're saying is then that 1 mole of octane releases 5060 joules. Okay, so what we want to do then is we want to say, well, what is the molecular formula mass for octane? You look at its formula, you go to a periodic table, you work out the sum of the various relative atomic masses, and you come out with 114 grams. So that says that 114 grams of octane is burnt to release 5060 joules. So 1 gram of octane, divide that by 114, that gives you 44 joules. Okay. Likewise with hydrogen, well, 1 mole of hydrogen releases 241 joules. That doesn't look much at first glance. However, 1 molecule of hydrogen weighs a lot less than 1 molecule of octane, only 2 grams, and so that releases 241 joules, and so 1 gram of hydrogen will release 120 joules of energy. That's just telling you, where we get these two figures from, where this figure comes from. Okay, so the mass of the fuel isn't so important when you're driving a car. It's very important when you're trying to launch a rocket. So hydrogen definitely comes off on top there. But one of the clear advantages of hydrogen, as we discussed right at the beginning of this lesson, is in the products that's produced when the hydrogen burns. Okay, and you remember that when hydrogen burns, the product that comes out of the exhaust pipe is water and nothing else. So that is really good news, right? Because there's no contaminants at all when hydrogen burns. However, petrol, when petrol burns, you don't just get water, but you get, which is okay, nothing wrong with that, but you also get carbon dioxide produced. That's not good news, because that causes global warming. And petrol also contains a whole lot of other stuff as well, which actually needs to be dealt with before it's chucked out of the exhaust pipe. So it has things called catalytic converters, which help to deal with the problem with the incomplete combustion of the fuel in the engine. Okay, so that incomplete combustion, as I've mentioned earlier, results in other products such as carbon monoxide and also carbon. So you're going to get a little bit, you're always going to get a little bit of this carbon monoxide and just pure carbon or soot, which is chucked out of the exhaust pipe. Okay, so these are also bad news. The carbon particles which are thrown out the exhaust will tend to gather on buildings, so you always find that, in the centres of towns where there's a lot of cars driving around all over the place, that the walls of the buildings, particularly if it's a city with nice, limestone buildings, for example, they will tend to get covered with soot as time goes on. So hydrogen has a massive advantage over petrol in that it is a clean fuel. Okay.